Let's talk about Project 2, Lesson 6. The Indianapolis 500 is one of the most exciting events in sports. Each spring, 33 drivers compete in the 500-mile race, sometimes hitting speeds of more than 220 miles an hour. Cars may accelerate to pass each other. Acceleration is measured in feet per second squared. Keep this fact in mind as you answer today's project questions. So our first question says, write a rational function that can be used to model the race, where the independent variable r represents the average speed in miles per hour, and the dependent variable t represents the time in hours it takes to complete the race. Okay, so let's think about what we're being asked to do. Our goal is to write a rational function that can be used to model the race. And we know that we need to use r and t as two components of this function. So let's plan out how we're going to do this. What past knowledge can we call on that includes distance equations involving rate and time? Well, hopefully you recall that distance is equal to rate times time. And we're going to base our rational function off of this relationship. So given that distance equals rate times time, we can now plan how we can create this equation we're being asked to make. Notice that our goal is not to have this relationship in terms of distance, but rather in terms of time. So the first thing you need to figure out is how can I manipulate this equation so that I'm solving for time instead of solving for distance. Secondly, once you have done that, notice that in the equation it tells us that we are to use r and t, but we don't have to use d for distance, because in this opening it tells us the distance of the race. So replace d or distance with the actual number of miles of the race. Once you've done that and have solved for this in terms of time, you will have your solution. The next question asks us, a car moves with initial speed v and accelerates with acceleration a. The distance d that the car travels in time t is given by the formula shown. Write a simplified rational expression for the average speed of the car. And our hint is that the average speed of the car is d over t, distance divided by time. Let's piece this apart a little bit. So first of all, what are we being asked to solve for? Well, we're being asked to write a simplified expression for the average speed of the car. And we're told that average speed is d over t. And if you think about it, this makes sense if we're going off our distance equals rate times time equation. If I wanted to solve for rate, I would divide both sides of the equation by t, and I would get that r equals d divided by t. So that's where that average speed of the car is d over t comes from. Okay, and we're being asked to solve for rate in terms of this equation. Now notice that there aren't any r's here. There aren't any r's in this equation. But there is a d and there are t's in this equation. So our goal is not to simplify this so that we have r equals something. Our goal is to simplify this so that we have d over t equals something. So our goal here is to solve for d over t, and we have to plan how we're going to do that. So notice that t appears in both terms. So one thing we can do is certainly factor t out of the equation, but it's up to you to take it from here and figure out how you're going to have d over t equal to something, and that will be the equation for the average speed of the car. Question 3. During a race, a driver accelerates 10 feet per second squared for 3 seconds to pass another car. The driver's initial speed was 264 feet per second. The driver's average speed during the 3 seconds of acceleration to the nearest foot per second was blank feet per second. Okay. Once again, let's consider what we're being asked to do. So we're asked to find the driver's average speed during the 3 seconds of acceleration to the nearest foot per second. And that's the number that will go in this blank. So let's plan how we're going to find this. Well, think about it. So we're being asked to find the driver's average speed. And what did we just calculate an equation for in the previous question? So you're going to use your previous answer, the solution you got, to solve for d over t. And you'll be able to plug in some numbers because we're told that the acceleration is 10 feet per second squared for 3 seconds, and that the driver's initial speed was 264 feet per second. So you'll be able to use all of that information to plug into your previous answer and solve for d over t, or the driver's average speed. Now be careful with your calculations in these 3 questions, because notice that the answers do depend on one another somewhat, so I really encourage you to double check all of your work.